So this is a little off the beaten track for me, and I swear I haven't been kidnapped by a Swedish philatelic group and forced to not talk about penny reds for a change. And you will be relieved that there are actually some penny red items in this presentation. This is a rabbit hole I fell down just before Christmas. I'd never heard of this guy, and as I started to research him, the only information I could find was in Swedish. The Swedes have a wonderful national biography set of volumes that they've been putting together for well over 100 years, and I guess it's in the National Archives. And biographies of influential and famous Swedish people. And I found this guy's biography and did I guess a Google Translate and set up a Wikipedia page because there was no mention of him on the English Wikipedia. He had a Swedish Wikipedia page. And I'll get towards the end, I'll get to the reason I went down this rabbit hole, which I can talk a bit about. But the more I read about him, the more I was fascinated by not just this guy's activities with regard to Swedish stamp production, but his entire life. He was, one of many 19th century people of, I don't know if his family was particularly wealthy, but he certainly didn't seem to have any trouble putting together capital to get into different ventures. Well educated, and in my amateur view, I think he had ADHD because he was one of these people who he would be fascinated by something and absolutely bury himself in the subject and learn all he could about it and perfect his skills, and then he'd get bored and move on to a completely different area of interest. And fortunately for the world, one of those interests for several years was stamp production, and fortunately for the country of Sweden and the post office. And for a couple of reasons, things that he did when he was involved in stamp production have impacts to this day that we'll talk about. He was born in the south of Sweden in Karlskrona, right down at the southern tip there. His father was a colonel and author, so he was from a noble family. His father was Count Georg Sparre, and I'm not sure how Sparre is pronounced, so I will probably interchangeably use Sparre and Sparre, even though there's not an accent on the E. I haven't been able to find any guidance on how it's pronounced. So he was born in 1828. The early days for industrial revolution and development in Europe, and right from childhood he apparently showed mechanical skill and inventiveness, which probably means getting into trouble, taking things apart. When he was 19, he was sent to the prestigious university in Sweden in Uppsala, which is north of Stockholm. It's like Oxford and Cambridge. It goes back to the 1400s, so it's a very it's got a lot of history, a lot of prestige. He lasted less than a year. Not sure what he was studying there, but his interests were obviously more hands-on and mechanical. So he went from there to a very famous engineering company called Motala Verkstad in Motala, which is in south central Sweden. And this company's around to this day. It was formed in 1822. It was involved in the construction of the Göta Canal, which is part of a waterway system which goes from the Norwegian side of Sweden right over to the Baltic. So it reminds me of our Trent-Severn system in Ontario in that it connects all these big freshwater lakes. The canal width is probably about the same as the Trent-Severn, maybe a little wider. It was built for commercial purposes, but presumably with defensive purposes in mind as well. The waterway goes from Gothenburg in the west of Sweden up through this lake system, and it comes out near Norrköping on the Baltic. So if you're the Swedish military, it's a nice bypass to get from the Baltic out to the North Sea without having to go by by Denmark, if that's something you need to do. So he spent about 3 years at Motala Werkstad. The document I read said he was a student there. I assume it was more like an apprenticeship, but I don't know how these companies were set up. It sounds like it was, a company, but they had an educational side to it too. And this company was involved in a wide variety of construction projects and fabrication. They were building ships. The top picture is of the world's oldest operating paddle steamer, which operates on the lakes are in Lillehammer in Norway. This was built by Motala Werkstad. The railway bridge is in Iran. They built the steel framework for the steeples on Uppsala Cathedral there. And the bottom picture is of the Nautilus from Jules Verne's 20,000 Leagues Under the Sea. In the book, Jules Verne says that the spur, the sharp pointy end of the Nautilus, was built by Motala Werkstad. So they actually got a reference in Jules Verne's novel. And the company's still in business today. Among other things, they fabricate the landing gear for Swedish aircraft, Saab aircraft. So Sparre was there for 3 years, and he left in 1850 with a lifelong affinity for military construction and a fascination with paper and paper making, which came in very useful. Soon after leaving Motala Werkstad, he became the first Swede to leave the surface of the earth. There was a Danish aeronaut named Tardini, Joseph Tardini, who was traveling around Europe with this huge silk balloon, which he would fill with hydrogen gas and undertake flights. And there seemed to be a group of these people traveling around Europe and the world trying to break records and become the first to fly from point A to point B. The same thing that happened when aircraft were invented in the early 20th century. There was sort of a race to be the first to fly to Australia or across the Atlantic or whatever. So Tardini came to Stockholm in 1851 with this balloon. The balloon on the right is not Tardini's balloon. This is a contemporary photograph from Persia, of all places, of a balloon landing there. Somebody took one to Persia to do a flight. So Tardini came to Stockholm and he put an ad in the paper looking for volunteers to go on a flight in his balloon. And Sparre responded to the ad and said, "Sure, I'll go." And apparently he was the only one. So in July 1851, the two of them took off in this balloon from the Tivoli Gardens in Stockholm and flew for about half an hour to the east and successfully landed. And then later that summer, made a second flight in the same balloon. 2 months later, Tardini had gone back to Copenhagen and was doing a demonstration flight there, which went wrong. He had a woman and child in the balloon with him, and the balloon started to descend uncontrollably. He jumped out to save the lives of the woman and the child. So Tardini died about 2 months after he'd done these flights with Sparre. And then as I was reading about this, obviously you read about hydrogen-filled balloons and you think, what the heck? And apparently, this was quite common in the day. And in fact, the first hydrogen balloon flight took place in 1783, the same summer that the Montgolfier brothers flew their hot air balloon in France. There was another aeronaut testing hydrogen-filled balloons in Paris. So the technology had been around as long as hot air balloons, and the obvious advantage is you don't need a big fire burning in the basket of the balloon. You fill the balloon and you're done. And I found this picture on the right. This is during the U.S. Civil War around 1862. The Union Army were using balloons for observation purposes, probably for targeting artillery. And they were using hydrogen gas to fill these balloons. So you can see they've got these two contraptions set up with some sort of chemical reaction going on inside, no doubt, producing hydrogen gas, which they used to then fill the balloon. And I guess at the time of the Civil War, there wasn't the weaponry or the accuracy to fire a projectile at a distant balloon. Otherwise, going aloft in a hydrogen filled balloon near a battlefield would have been a suicide mission. And then another rabbit hole, helium wasn't used because it hadn't been discovered yet. 1868, it was discovered in the spectra of the sun, and then it wasn't discovered on Earth until 1895. And it wasn't until the 1900s when they started developing natural gas resources in the U.S. and elsewhere that they discovered it in quantity in the natural gas caverns deep below the Earth, which is to this day is where all of our helium comes from. Because once it gets into the air, it rises and disappears. So the next year, 1851, the Riksbank, the central bank of Sweden, had a banknote printing plant manager position come available. And Sparre, who had an interest and some background in paper making and printing, decided to apply. And being 23 years old, he decided that the best way to impress the bank would be to produce counterfeit notes in the 2 Riksdaler denomination. And he produced these apparently amazing counterfeits. The note I've shown here is I think a real one. It's not one of the counterfeits. But he produced these amazing counterfeits, and they could only be detected because he put his name in the watermark. So if you looked at the watermark, you'd see his name, and so you'd know it was not a real note. Unfortunately, the stunt wasn't effective, and the job was given to an older, more experienced gentleman named Jonas Baga, who had up till then run the Swedish paper mill at Tumberbrook, where all Sweden's security papers were made, the high quality, handmade, high rag content paper was made there. And he developed a new banknote paper for the Riksbank in the 1830s, so they had a good relationship with him and were confident he would do a good job managing the printing of the banknotes. They were still impressed with Sparre, though, so they gave him Bag's former job managing the Tumberbrook paper mill. And Sparre was there for about a year, but ran into personality problems. Again, he was only 23, 24 years old. And the accountant at the paper mill was the brother-in-law of Bag, who had just left to go to the banknote production company. So apparently there were some conflicts, and after about a year, Sparre left. But he had some additional experience with paper production and security paper production. So shortly after, in 1854, the Swedish government, seeing what was happening around the world, decided to introduce some reforms to their postal service, much along the lines of what had happened 15 years earlier in Britain, and that is to set a uniform rate for domestic letter postage by weight, regardless of the distance within Sweden, and to move towards prepaid postage, and so therefore to somehow get postage stamps produced. Because Sparre had dealt with a lot of these people, and there were people who maybe felt bad that he hadn't got the position running the banknote company, he seemed to have an inside track. So in 1854, the Riksdag, the parliament, made this decision to introduce uniform postage and produce stamps. And then in early 1855, they confirmed this decision. Presumably, the king signed it into law. And at this point, Sparre had already been in negotiation with the General Post Office to produce stamps, and in fact had already been buying equipment in England, presses, and had set up a print shop in Stockholm by early 1855 with a staff of 3 people, even before he'd been awarded the contract. So he was clearly confident that he was going to get the contract. And thus it was that this was the guy that produced the first Swedish postage stamp. So it's a set of 5 in 5 denominations. 3, 4, 6, 8, and 24. Skilling Banco was the name of it, was the currency at the time, and it was changed a few years later. But the Skilling Banco is what appears on the first stamps and on the currency at the time. They're classic stamps for various reasons, and completely the product of Sparre's ingenuity and work. This guy designed the stamps, engraved the master dies, figured out the process to print them as secure items. In other words, so to reduce the odds of them being counterfeited, and also designed and built the machine to perforate them, and that's how I came into this rabbit hole was through his work on stamp perforation in the mid 1850s. So in the spring of 1855, he was given the contract, and his little company went nuts. So he was doing the engraving of the master dies. The first set that he did were rejected by the post office, and he had to re-engrave them. And he also had to work out how to duplicate the engraved die using cliches, and we'll talk about that. Assemble the printing plates, do the actual printing, and perforate the stamps. And, as you'd expect, he ran out of time. So his contract was to deliver a big lot of stamps for 2nd of June, 1855. But he only missed it by a week and a half, and he was able to deliver a lot of stamps, and in fact, was shortly able to satisfy the post office that he could deliver enough stamps for their needs over the summer. So obviously, as a British line engraved collector, everything I look at and read about and think about is the British line engraved stamps are sort of the benchmark for comparison. So what I thought I'd do is sort of run through the decisions that were made and the things that were done to produce these stamps and compare them to what was happening or what had happened in Britain in the preceding 15 years. And just as a sort of a high level comment, there were advantages and disadvantages to this. The disadvantage was he was not a kid, but certainly a young man, very ambitious, very confident, and not necessarily capable of producing on time or the quality that was needed. But he certainly took a good shot at it, and for the most part succeeded. The advantage he had over the Brits, the other disadvantage he had was when the Brits put together their penny blacks, they hired one of the best engravers in the country to do the engraving. They hired Perkins Bacon, who had decades of experience doing security printing and had come up with their own siderography technique for transferring images securely onto steel plates. And they were hired to do the printing of the penny blacks and had that contract for 40 years. When it came to perforation, Henry Archer came to them with the patents for the first perforating equipment. And so there were a number of very skilled, very bright people who came together to produce the British stamps. And arguably they stand as some of the most successful and beautiful stamps ever produced to this day. Sparre did all of this on his own. And so there was a negative side to that, but there was a positive side in that when he got to the point of perforating, he'd thought through the problems that the Brits had and used a different approach for laying out his plates, which actually helped him come up with a more successful perforation strategy, and we'll get to that. So engraving the dies, if we compare the 4 Skilling Banco, the blue, with the penny red in use at the time in July of 1855. One of the great features of the British penny stamps was they used Perkins Bacon had access to this what they called engine turning technology, and it was the ability to use geared mechanisms to engrave very fine, very intricate backgrounds. And we see these sorts of things even on our currency today, on our notes and stock certificates and so on, these very intricate backgrounds. In 1840 and into the 1850s, this was new technology and was quite amazing that they were able to produce this. The image on the right is a blow up of the background of the skilling stamp, and clearly it's been hand engraved, not using the engine turning technology, but Sparre has actually done a pretty good job of creating a pretty secure background to the stamps, an engraved background to the stamp. And again, he did all the engraving himself, 5 master dies. The foreground on the British stamp, this amazing profile of the young Queen Victoria. Again, one of the top master engravers in Britain at the time was retained to produce this image, and it lasted for 40 years on the penny and the tuppenny stamps. Sparre chose to do the national coat of arms, I think pretty obviously, because it's a lot easier to produce a good engraving of a coat of arms than it is of a human head in profile, unless you've had a lot of years of experience. And then the text on the stamps, again, fairly elaborate serif letters on the British stamps, and a much simpler sans serif engraved alphabet used on the Skilling Banco stamps. I'm not going to get into how the British produced the plates. I think I've talked about that before at great length. Sparre chose to use a different type of printing, not intaglio printing, which is what the Brits were using, but to use letterpress printing, in which it was the raised surfaces of the plate that held the ink. So it was the same way, for example, newspapers were printed and books were printed at the time. The raised surface holds the ink, and so when you engrave, you're taking away you're not creating deposits for the ink. You're taking away the metal that you don't want to hold ink. The process for producing plates from these master dies, once the master die was created, was to create cliches. 100 cliches from each master die for each plate in typesetting metal, and we'll talk about that, and then to assemble these cliches into a 10 by 10 grid. So the plates that he used were 100 stamps to a plate in a 10 by 10 grid. These are images, obviously that's Edward VII on the left. So these are images taken from a presentation on a very similar process, but a much more modern process than what Sparre was using. And at the very end, if anybody's left on the call, I'll talk quickly about the difference between this later method, which is called electrotyping, and the method that Sparre used. But in a nutshell, you start with an engraved master die on the left. You put it in a collar, and what's being shown here is they're using a hydraulic press to press a lead slug into the die, so that the reverse of the master die image goes into the lead slug. What Sparre did was very similar, except he was pouring liquid metal onto the die. So he'd encase the die and then pour liquid metal onto it, typesetting metal, and then when that cooled, they would separate, and he'd have a reverse image of the die, and that was called a cliche. So he'd cast 100 of those, and then assemble them into a grid, lock them into a frame, and that for Sparre was the printing plate, the 10 by 10 grid of cliches. The middle image here with the sort of coppery tone, that's the Prince Edward Island 4-pence black stamp, how it was produced. The plate actually survives. This is done using electrotyping, and again, I'll talk a little about that at the end if anybody's interested. It's a slightly different process, but it's essentially the same. It's taking an image, it's taking a whole series of images from the master die, assembling them into a frame, locking them together, and that gives you your printing plate. So what's interesting about that? I mean, it was a very different method than the Brits were using, than Perkins Bacon was using. Um, but it worked and was widely used in the printing industry, not necessarily for stamps, but certainly for other books and I don't know if they were using it for, anyway, it doesn't matter. It wasn't a method that Sparre invented, but it seems he simplified it. He didn't use the electroplating. He just did a very simple metal cast of the master dies and assembled them into a frame. What happens when you do this, though, is each cliche, each casting from the master die is potentially different. It'll have very slight, very tiny differences, the sort of thing that philatelists love to search for and have spent, the better part of 160 years searching for. And even though there's no registration sheets and there's no corner letters on the stamps the way they're on the British stamps, Swedish philatelists over a long period of time have been able to recreate the plates that were used for the four-skilling stamp. There were 3 plates, and part of the challenge is at various times Sparre would disassemble the grids of cliches and pop a new, if one of the cliches was getting worn, he would pop a new cliche in or take one out and use it in a different plate. So it's a very complicated recreation process that's gone on, that's talked about at length at the beginning of the Facet Special Classic Catalog, the 2024 edition. There's a whole article on plating of the four-skilling banco, and the four-skilling is the one that's been plated because that's the stamp of which there's the most copies. Four-skilling was the standard postal rate. The three-skilling was a lower rate. I suspect it might have been for newspapers. Most countries had a reduced rate for journals and newspapers, and then the higher value ones obviously would be less common. So the four-skilling is it's not a common stamp, but it's more common than the others. And like I say, over 160 years or so, people have been able to recreate the 3 plates and the variations on those plates that occurred when the cliches were moved around. And this is a page from the Facet catalog that shows the sorts of features that they're looking for, the kinds of variations from cliche to cliche. That has allowed them to reconstruct the plates. And then obviously, like every other early issue, there's color variations, there's plate wear, there's sometimes more ink was loaded on the plate than in other times. So you get all sorts of variation. And sometimes this can feed into the plating detective work as well. And then we get to what I call the interesting bit. Sparre had to find a way to perforate the stamps, and he was aware of what they were doing in Britain. So it was late 1854 when he was working out how he was going to do this, produce these stamps. And so by that time, the Henry Archer perforation trials were done, are coming to an end in Britain, and the British Inland Revenue Department had decided to go ahead with and acquire Archer's patents, and hired a company called Napier to build a series of machines to be used at Somerset House, and that's where the official perforation of the British stamps was done. So Sparre was aware of all this, and in fact, at some point in 1855 or 6, visited Somerset House to see the British perforation process in operation. What he did, being a young, brash, inventive guy, was he went away and said, well, there's got to be a better way of doing this. And he came up with what is now called a Harrow perforation machine. As far as I can tell, this was a Sparre invention. I haven't come across any mention of the method being used before. Certainly not on postage stamps, because he was producing perforated Swedish stamps in the spring and summer of 1855. That's within months of when the British released their officially perforated stamps. So the Swedish perforated stamps are among the earliest perforated stamps in the world. There weren't a lot of other I don't think there were any other countries producing before Sweden, other than the UK, obviously. So the basis for this harrow machine was that instead of a series of successive strikes of a perforating comb or a line onto a sheet, you had this massive grid of pins, and you'd bring it down and you'd perforate the sheet in a single strike. And I'll show you what the results of that look like. And it's actually it's one of the time honored decisions you go through in engineering is, do you invest up front in producing a more elaborate machine that saves you time as you're in production, or do you produce a less complicated machine, but then it takes you a lot longer to produce whatever it is you're producing? So with the comb perforation method that was used in Britain and the line perforation machines that began to be used in America and Canada and other countries, to perforate a single sheet, the British machines required 21 successive strikes to work their way a row at a time down the sheet. On Sparre's machine, you could perforate that sheet in a single strike and then move on to the next sheet. So this is the comb perforator developed by Henry Archer in the late 1840s and tested for 4 years. And then, as I said, the Post Office, Inland Revenue actually acquired the patent from Henry Archer and set up a perforation operation in Somerset House. So the reason it's called a comb, you can see the blue arrows point to, there's a horizontal line of pins, and then coming down from that are what are called spur lines, which are vertical lines of pins. And one strike of this gives you the top edge of the stamps in a row and the sides. And then you pull the pins out and you shift the sheet up one row, and then you do the next row, which gets the bottom of the first row and the top of the second row and the vertical sides in the second row. So to do a complete sheet of 20 rows requires 21 strikes. You need the 21st strike at the end to get the bottom of the 20th row of stamps. And every time, the art to this is synchronizing the movement of the sheet a row at a time through the machine, and then the strike of the comb with the pins. And this was the genius of Henry Archer that came up with this method. This is the bottom of a sheet that was comb perforated in 1876. This would have been done on the Napier machines. This was long after Archer had been involved. And you can see in the bottom selvage, there are vertical perforation lines, and that's because of the 21st strike of the perforating comb that was required to get the bottom edge of the stamps in the T row. So the characteristics of comb perforation, as I just said, is on one of the margins you'll have a full row of holes in the selvage, as shown here. And sometimes it's to the side. Some perforators later on, the sheets were fed sideways, and so you'd get the lines of perforation to one side or the other. But typically, these lines occur in only one of the 4 margins of the sheet. The next feature is that if you have a defect or a feature in the comb, in this case a missing pin, that feature is repeated on every row. So the blue arrows point to a missing perforation pin, and you can see that occurs on the S row, the T row, and then even in the selvage, the vertical line in the selvage has the same indication of the missing perforation pin. And then the other thing that happens, and we'll talk more about this in a bit, is that you get variation in the spacing between the last vertical pin of the strike in a row, and then when the sheet is advanced, the operator has control over how far the sheet advances, and so depending on the sheet and the weather condition, humidity and so on, they might change the amount that the sheet advances from row to row. And so you can get variation in the gap between that last hole in the vertical line and and then the horizontal row of the next line, perforation line. And you can sort of see that here. The gap at the top between the G and the S is fairly big, and then between the G and the T, it's less of a gap, and then between the G and the salvage at the bottom, it's gotten wider again. So the operator can set on these machines the movement between each strike, but then they can fine tune it as they go along. If they see that the line of perforations are drifting out of the margin into the stamps, they can pause the machine and adjust that setting so that they get a cleaner perforation. The goal obviously being to get the lines of perforation into the margins between the stamps as best they could. Line perforation, as I said, commonly used on American and Canadian stamps. And it's quite obvious when stamps have been line perforated, as most of you will know. For one thing, you get well, the way it works is you do one or more single lines of perforation and strike after strike after strike down along the margins, and then the sheet gets rotated 90 degrees, and then you do the orthogonal line. So you do horizontal first followed by vertical or vice versa. And in some cases, a different perforator would be used. So you'd run the sheet through, say, the vertical lines and then rotate it 90 degrees and put it through a second machine to do the horizontal lines. And there are cases, such as in this series of Canadian stamps in 1873, where the perforation gauge is different. This is an 11 and a half gauge horizontally and a 12 gauge vertically. Well, it's because it's line perforated that this could happen. It would not happen in a comb perforation unless it was done intentionally. The biggest feature of line perforation is if you look at the intersections in the corners of the stamps, they rarely line up. And in fact, on this block, you can see there's 9 intersections and every single one looks different. So there's not even consistency between the way the horizontal and vertical lines meet. It ends up being a little bit of a mess usually. And then, as I mentioned, you get the perforation lines into the salvage usually on all sides in a line perforated sheet. So it's one side in comb perforation, potentially 4 sides in line perforation. And as I said, this block is 11 and a half gauge horizontally and 12 gauge vertically, which can only happen with line perforation. And then here's the results of harrow perforation. So this is the machine that Sparre developed. And so right away you can see that it's a very neat imprint. There's no perforation lines in the salvage, either below or to the side. And that would be true. There are no surviving sheets, but it's well known the way he was doing this, and there would never be perforation lines into the salvage. As I said, the obvious advantage to this is that it's much faster than comb or line perforators. Single strike and the sheet's done, and you can move on to the next sheet. Comb or line, multiple strikes, potentially dozens of strikes to do a single sheet. What that means is you also have wear and tear on the perforator. You're actually, every strike is a little bit of wear and tear. So you've got more work that goes into creating a harrow perforator, and there's a lot more pins, but over the life of the perforator, there's less wear and tear because you're only striking once per sheet. And it also means, because of the faster throughput, you need fewer machines. So the Brits were using about 4 machines at the height of penny red production. Sparre used 1 machine. Now, clearly, Sweden didn't have the demand for stamps that Great Britain did, but more or less, you would need fewer machines to perforate with a harrow perforator than with a comb perforator. This is actually a 150th anniversary of Swedish Stamps souvenir sheet, and with Sparre featured on it, an image of Count Sparre. And ironically, souvenir sheets are harrow perforated to this day. That's how you get that pristine block of perforation. There's no multiple strikes with a souvenir sheet. It's a single strike to get all of the perforation done. And arguably, I mean, this is a block of 9 stamps, which is a very different proposition than producing a perforator for a 10 by 10 sheet of 100 stamps, but it's the same idea and it's the same method, which is still used today. As I said, the perforation lines never extend into the selvage with harrow perforation, and you get perfect alignment of the horizontal and vertical lines. Now you get more or less perfect alignment with a comb perforator, but with the harrow perforation, you get equal spacing between the holes because that's all laid out by your machinist when he's producing the perforation comb. So it can be as precise as you want it to be, and that precision is not going to change as the perforation. I keep wanting to say comb. It's not a comb. As the perforator is used, it doesn't wear out, and you don't have to worry about adjusting it for paper or humidity conditions or anything like that. The other thing I saw in the facet catalog is there is, I think, just the one missing perforation pin error that they have found over the years. It never occurred in the four-skilling stamp, but you can see the third perforation down with blue tape under it on the 3, the 6, and the 8 skilling stamps. There's a missing perforation pin in that location. And then because the harrow perforator was a human creation, there'd be subtle variations in the alignment of the pins. And again, these things were fabricated in 1855, 1854, no electricity. And yes, there were, amazing machine tools available and techniques. I mean, people were making watches with tiny gears going back 100 or 200 years before this. So there were methods for doing very precise machining. Notwithstanding that, between the need to get these things done on time and also there would be some wear and tear, there are variations in the alignment of the pin, the spacing between the pins, and whether or not they're completely linear. And again, students of these stamps over 160 years have recreated sheets, the plates, using the harrow perforator as the guide. They've recreated how the pin alignments varied from stamp to stamp and been able to use that to assist in plating. And again, it's the 4-skilling Banco they've done. There's just not enough copies of the stamps of the other values to allow them to do this. So in 1856, Sparre sent a letter to the Brits saying, I have this wonderful perforation machine. I'm not sure if he called it a harrow perforation machine, but that's what he was referring to, and outlined the advantages that he thought it had over comb perforation. And he knew at the time, he'd been to visit Somerset House and see the British perforating operation running on their 4 Napier machines. And he knew they had some problems. And a lot of these problems tie right back to the subject of my exhibit, which is about how the alignment of images on the plates wasn't as precise as you might expect. And so you'd get variations in, the margins would shift around, the margins would vary in width. And on top of that, the Brits printed their stamps on wet paper, and then it would dry to some extent before it got to the perforating operation, because the stamps were printed at Perkins Bacon and then sent to Somerset House, the building in the image here. The Inland Revenue Department had control over the perforation for some reason. And that changed later in 1880 when De La Rue took over the printing contract. But from 1855 to 1879, 24 years, the stamps were printed by one organization, Perkins Bacon, and then perforated by the Inland Revenue Department. So Sparre sent a letter to Inland Revenue in Britain explaining what we've been talking about. The comb perforation was slower, requiring 21 strikes per sheet, as opposed to one strike for a harrow perforator. As a result, the Brits needed 4 machines, whereas with a harrow perforation system, they might get away with 1 machine to meet their needs. And he was convinced that because the sheets were being advanced and struck multiple times, this led to inaccuracies, that the sheet might shift laterally or vertically, so it would add to the inaccuracies they were getting in their perforation, just by virtue of the fact that this sheet was being hammered 21 times by these punch sets. And then obviously they needed more punch sets because of wear and tear, because each punch set was used multiple times on a sheet. Thus started a bit of a debate in the British Post Office and between the British Post Office. Ormond Hill, who was a relative of Rowland Hill, was in charge of the post office at the time, and got quite defensive about the comb perforators that were being used. And so the British response to Sparre, I don't know if they ever sent him a letter, but certainly in this internal debate, they said, well, because the paper is printed wet and then dried to some extent before it's perforated, the operators need to be able to adjust the spacing of the comb strikes, and you can't do that with a harrow perforator. You set the harrow perforator up for a particular spacing of stamps, horizontally and vertically, and then it's locked in. You can't change that. You'd have to build if you found that things were changing, the printing methods had changed, or whatever was happening, you'd have to create a whole new harrow perforator to deal with the changed conditions. And what you can see on this item on the right, it's a stamp with salvage from 3 stamps, is between row 2 and 3, the vertical line of perforation shifts to the right. And this is because the operator, after doing so, we've got row G is the stamp, the next row would have been H. Between row H and row I, the operator realized that the vertical perforation lines were drifting off the margin, so he paused and he shifted the sheet to the left to correct the misaligned vertical perforation lines. You can't do that with a harrow machine. And you don't see a huge number of examples that are this clear, but you do find them in the British stamps where the operators are actually intervening and correcting for problems in the perforation process. We talked about the spacing between the last vertical perforation hole and then the horizontal line at the top of the next row. That's something, again, this reflects operator intervention. The operator has changed the spacing between the rows to correct for a drifting perforation line, something that wouldn't have been possible with a harrow perforator. And then there's something that wasn't talked about in the letter, but I think is sort of the nub of the situation. This is a block of a very expensive block of 4 Skilling mint stamps. It's absolutely not something that I own. I've got a single measly used copy of the stamp. But what you can see is the margin width is huge between these stamps. And that was done quite intentionally. Sparre was the one who, came up with the stamp design and figured out how to, make the clichés and lock them together. So he absolutely had control over the margin width. In fact, they would use spacers between the clichés sometimes to adjust them so that they would line up properly and give the proper margin width. The Brits had locked into a plate production method in 1840 and had locked into a margin width because they had this handmade paper coming down from Rushy Mill. And so the sheets of paper were a certain size. And when they designed the layout of the stamps on the sheets, they wanted to optimize. They wanted to get as many stamps as possible on a sheet of paper because the paper cost was probably the biggest input cost to the whole process, more than the ink, more than the labor. Um, and so their objective was to get as many stamps as possible onto a sheet. And so the margin widths are minuscule compared to the margin widths that Sparre was using on the Swedish stamps. And obviously, with these much narrower margins, it's that much harder to get the perforation lines lined up. And the narrow margins on the British stamps, coupled with the fact that there was still drifting of the images, that you can't really see it here, but even in 1876, which is when this block was printed, they still had sometimes significant misalignments from image to image on the plate. They hadn't solved this problem at the printers. And I think part of that was because the printing and the perforation were done by different organizations, they didn't have a proper quality control feedback loop. The printers said, okay, this meets our standards, and the perforators would look at it and say, well, what are we going to do with that? We can't perforate that. And there were the occasional plates that were rejected for that reason, the most notorious being plate 77, of which only a handful of stamps accidentally got out and survived. So there were plates that were rejected, but for the most part, the perforators in Britain just had to do the best job they could with these tightly spaced, occasionally misaligned stamps. Sparre was aware of all of this very likely and said, I'm going to solve that problem by spacing my stamps out more. I don't care if, I need bigger sheets of paper to produce the same amount of same volume of stamps. It'll save time and therefore money in the perforation process, and that's exactly what he did. So, being the type of guy he was, after 3 years of this unbelievable creativity and hard work and success in producing stamps, he decided he'd had enough and moved on. And a guy named George Schutz took over the printing operation in 1857. I think Sparre was probably happy with his success as a stamp manufacturer, but his interest still lay in engineering and vehicles, artillery, firearms, ammunition, bicycles of all things. And so in 1861, a few years later, he moved to Paris, and he remained there until he died in the 1900s. He married there and had a son in 1863, and being a person of means, he was able to spend his time coming up with designs and inventions, different types of security paper, weapons, bicycles and bicycle tires, flying machines, underwater vehicles, and of all things, devices for closing bottles were listed in his biography. But the observation of the biographer was that he, because of, he was jumping from interest to interest and challenge to challenge, therein lay his weakness, because he wouldn't pursue these things to fruition. So, the 3 years he spent producing stamps was, arguably the most successful period of his life, and that was in his mid-20s. Every other thing he took on, he'd be very optimistic about it and maybe have amazing ideas and attract stakeholders. And then ultimately, for whatever reason, the project wouldn't work out and money would be lost. But he'd be okay, because he'd move on to the next idea, the next challenge. In the 1890s, he began work on creating a modern bicycle. Cars, automobiles were beginning to be produced, and he was very skeptical about them, unreliable, requiring maintenance, and he was convinced that they would easily tip over. And in fact, if you look at some of the early automobiles on those very large diameter wheels, very high up off the ground, you could believe that they, in a high wind, might be tipped over. Ultimately, his work led to an idea for puncture-proof solid rubber tires called Sparre tires. And the frustrating thing about Sparre tires is, if you Google that to try and get more information, you get page after page about spare tires with one R, but absolutely nothing about Sparre tires. But he came up with this idea and convinced people it would work. But they did some tests, and at the end of the day, it turned out that it wasn't such a good idea after all, for whatever reason. He'd had a fascination with balloons, having been an early passenger in 1851, and had ideas about heavier than air vehicles. He put a lot of thought into a flying machine that could take off straight from the ground, and essentially what became the modern helicopter. And it was 1923 when the first autogyro flew in Spain, so he was well ahead of his time. And also he had some expertise in ship design and production, from his years at the engineering works in Sweden, and turned his attention to things like underwater vehicles and submarines. And I've put an image in here. It has nothing to do with anything Sparre did, but this was early 1860s. The French produced and he did do some work for the French military and the French government, particularly during the Franco-Prussian War. He may or may not have had a hand in designing this vessel. There's certainly no indication. It's a 12-man submarine, and it's the first non-manual powered submarine in the world. It was full of huge tanks of compressed air, and the compressed air would be used to drive a reciprocating engine. So this thing could travel underwater for several kilometers. And the big spike at the front has an explosive on the end. This is an early torpedo. It's not something that independently travels through the water. It's something you poke a ship hull with this thing, and it leaves the explosive there, and then you get the heck away before it blows up. Died in 1921 in Paris. Still in Paris. Buried at a big cemetery south of Paris, and his tombstone apparently has his Latin motto carved into it, which is an ingenious motto, Perge animo sparare, which is similar to his name, Per Amstead Sparre, and in Latin it means never cease to hope. So his legacy, the Harrow perforator, obviously, it has been used on complete panes, and I'm trying to remember, somebody mentioned to me at some point, either in Britain or I think in Canada at some point, they used Harrow perforation on full panes or full sheets. But obviously souvenir sheets. I mean, that's how souvenir sheets are produced. You couldn't do it with a cone perforator or a line perforator, or if you tried, it wouldn't look nearly as attractive. And then perhaps his most famous legacy, towards the end of his work producing stamps in Stockholm, somehow a sheet of 3 skilling stamps got printed in the 8 skilling color. And in the heat of production, and with plates, different plates on different presses, and 3s looking a lot like 8s, and also the plate being in reverse, so you got to read it in reverse. You could imagine this happening. Somebody was at a press they thought they had the 8 skilling plate, so they put the 8 skilling yellow ink on it, and it turned out it was a 3 skilling plate, so they got a sheet of 3 skilling stamps in the 8 skilling color, this beautiful yellow gold. Of these stamps, only one has survived, and this has become a legendary rarity. The last public sale in 1996, $2.3 million, and it's changed hands a couple of times since then, but privately, so nobody knows how much it's sold for more recently. So that stamp, which many of us are aware of, the 3 skilling yellow Swedish stamp, Sweden #1, was in fact produced by Sparre, more or less accidentally.